Modern programming requires us to process massive amounts of data constantly, but handling that data comes with a strict requirement: reading and routing the information without accidentally altering or corrupting it in the process. To meet this requirement in Python, we use the tuple. Think of a tuple as a read-only vault for your data sequences. Once information goes in, it cannot be changed. But a locked vault is only useful if we can efficiently inspect what's inside. That requires our second tool, the for loop, an automated engine designed to scan through data one piece at a time. Manually extracting items from a dataset works fine if you have 3 items. For 3 million, handwriting every access command is a human impossibility. Automation is the only viable path to managing data at scale. Our objective today is to build a secure, automated script. We're going to write a program that systematically reads through a sealed sequence of data, item by item, while guaranteeing the original information remains intact. Combining loops with tuples creates a highly reliable read-only pipeline. It gives you the speed of automated processing with the total security of locked data. Step 1 is setting up our workspace. Open your code editor and create a blank Python file so we can build our first data container. This diagram shows exactly how tuple syntax works. We place our items, apple, banana, and mango, inside standard parentheses. The moment we close those parentheses, Python locks the container. This is called immutability, meaning the data sequence is now permanently fixed. To extract a specific item from this locked sequence, we use the zero index rule. Computers start counting at 0, not 1. So when we command Python to print index 0, it points directly to the first item and outputs apple to the terminal. These index numbers act as precise lasers. They allow you to surgically target and view individual items inside the vault without ever opening the door. Pulling items one by one using index numbers is inefficient. To handle data at scale, we need to instruct the computer to cycle through the entire vault automatically. We do this by building a for loop. The syntax for item in fruits acts as our automation engine. It tells Python to inspect every single element inside our tuple. The loop executes a precise series of microactions. On its first cycle, it targets position 0, extracts apple, and prints it. Without pausing, the engine pushes forward to position 1, reads banana, and generates the next line of output. Finally, it reaches position 2. It prints mango, recognizes there are no more items in the sequence, and stops. The entire extraction process happens in milliseconds. This introduces a new operational challenge. How does our script know exactly how many items are in the sequence if we don't manually count them beforehand? Python handles this with the len function. It is a built-in measuring tool designed specifically to calculate the exact size of sequence data. To use it, we simply wrap our tuple variable inside the len command and wrap that inside a print statement. Look at this graphic visualizing the calculation. The len function spans our data block, measures the elements, and immediately outputs the total, 3. By pairing loops with the len function, you transform a static block of silent data into a dynamic, self-reporting system. Now, let's move from simple lists of fruits to a realistic system structure. We'll construct a student profile tuple containing mixed data types: the string Rahim, the integer 20, and the string Dhaka. Structuring profiles as tuples rather than standard lists is an intentional architectural choice. It ensures that critical identity configurations are safeguarded from unauthorized edits. Watch what happens if we deliberately try to overwrite index 0 with new data. The command is immediately rejected by the compiler, and the terminal halts, throwing a type error. This crash demonstrates the Python interpreter enforcing the tuple's constraints. It serves as functional confirmation that the data cannot be altered once it's locked. Let's review our completed workspace. We have a clean script that creates a locked data container, dynamically measures its length, automatically extracts the contents, and blocks any malicious overwrite attempts. We started by securing raw data. We learned to target specific items using index numbers, and we built an engine to fully automate the extraction process. These operations form a consistent pattern for data handling. You are creating scripts that process information predictably while protecting the original source from unintended changes. Now it's your turn. Open your editor and implement this read-only iteration pattern with your own datasets. Practice building these tuples and loops until the syntax becomes muscle memory. Mastering these foundational structures is how you write professional, error-resistant software. If you found this breakdown helpful, like the video, subscribe for more programming content.